So hello guys, today we are going to cover the dynamic memory allocation in C++. So let me quickly show you what we are going to do. So we are going to see the dynamic memory allocation of 1D array and 2D array. Okay, so we are going to see both of them, and at the end of this video I will be very clear, and I think I can make any dimensional array after this by using dynamic memory allocation. So let me first of all show you the concept behind the dynamic memory allocation. So while doing dynamic memory allocation, so we basically make a space in the heap memory. So in the heap memory, we make a space, and we allocate our elements, or we can say value, in that space. Okay. So while doing static allocation, it is created in the uh, I think static storage, stack memory. I think so. So while in static allocation, it is created in the stack memory, but dynamic allocation creates this space in the heap memory. So uh, the main thing is we can allocate the value, we can allocate the storage in the runtime. Okay, so that is the main benefit from this. So let's see how can we do this in C++. Okay, so first of all, let's see the 1D array dynamic allocation. Uh, you can see, so I have firstly shown the enter the number of elements in the array. So I have asked for the number of elements, and I have inserted it inside of the variable n. So now this is the main point. Okay, this is the main line for dynamic memory allocation. So while doing dynamic memory allocation, we always use pointer. Okay, so we always use pointer, and that pointer does what? That pointer stores the address of that storage, wherever it is that storage element, that address is stored. Okay, so let me just quickly show you what does this line does. Okay, so I will give you some pictorial visualization so that it would be very easy to understand. So this may not be technically correct, but this is the visual representation, visualization. You can imagine it like that to remember and understand. Okay, so I think I will not be that much wrong, but I don't think this is written anywhere. Maybe uh, it is not technically proven or anything. It is not written anywhere. Okay, so I am creating this logic. I am creating this visualization. So. So whenever we use this, whenever we create a pointer named ptr, so we are creating a pointer named ptr, and we use new keyword, okay, new new keyword to make for the dynamic memory allocation basically. So and after that we give inside of the we give the data type and the what is to be given what we don't use variables here because variable is our pointer already. So for in case of array we use big brackets, and inside of that we give the size of the array. Okay, so for the this is for the 1D matrix or 1D array, and we will see for the 2D array as well. So basically we are giving the size of the array. Okay, data type and size of the array. After new keyword we are giving data type and size of the array. And if you want to allocate dynamically for the values or characters, okay, so for that we need to use int, and inside of this instead of using these big brackets we can use small brackets and give the values. Okay, so and you can use character char for allocating the characters. Okay, so in that case we use these small brackets. So in case of array we use big brackets, and inside of that big bracket we will pass the size of the array. So that is it, and I will quickly show you what is happening here. So we are creating this size of array. Okay, this size of array we are allocating dynamically in the heap memory, and this ptr is the variable which is storing that address. Okay, so this is heap memory. Okay, so we can imagine it like this kind of storage elements are created in the heap memory. Okay, so these kind of storage elements, that is where we can put the array elements. So these kind of array elements or storage elements are created in the heap memory, and this int ptr we are with int asterisk ptr we are initializing that ptr. Okay, so this ptr will store the element of this block, the whole block. Okay, so how can it store the element of the whole block? That is very not so relevant thing to ask, because because now we will see that this PTR will be divided into many parts. Okay, many that means it will give them different variable names so that it can store the address of each of the blocks, right? Each of these cells, we can say these storage cells, uh, like like we can now assign the storage address. Okay, so I want to assign storage address of this first block as ptr 0. Okay, and then the second address is ptr 1, something like this. So and then ptr 2. Okay, something like this. Then ptr 3, then ptr 4. So this kind of thing we need to do to assign each of the block address, each of the cell address, where we will add the values later. Okay, this each of this address should be assigned to the pointer. Okay, so this ptr is reflecting the addresses of all the blocks, of all the elements that we have just located, that is dynamically allocated. Okay, but this ptr 0, ptr 1, ptr 2 are responsible for storing this, are associated with storing the address of each of the cell of their dynamically allocated memory. Okay, so we will see this thing here. You can see we can give any number to this. So let me just make it just like I have. Oh no, oh no, bro, electricity had gone just for a minute. So I have just made the same as here. Okay, so that it will be very easy to understand. We can understand it like, you can see inside of ptr I, that ptr I means we are using for loop from I equal to 0 to less than n. Okay, so that means it would go, it would, what is n? N is the number of elements in the array. So it would go from, if the number of elements of the array is 5, then it would go from 0 to 4, 0, 1, 2, 3, 4. Okay, so and we are taking input inside of this ptr I, that means ptr 0, ptr 1, ptr 2, ptr 3. So this variable name will be assigned to that block. Okay, now that means this variable name, that is ptr 0, is assigned, is associated with storing the address of this block. What is this happening, bro? So, and ptr1 is associated with storing the address of this block, this element, storage element, and ptr2 with this, ptr3 with this, ptr4 with this. So we are just assigning different ptr so different variable name to store each of the element. Okay, each of the element storage. So that is we are doing here, and also we are inside of this each of the, we are doing two things here. Okay, we are doing two things here. We are also storing the variables and also giving it a pointer name, pointer variable name. Okay, a unique pointer variable name we are giving for each cell. For each cell we are giving the pointer variable name, and also we are assigning some values here. Let's say I write 5, 4. We are taking input from the user to write the elements inside of this cells, and 1. So something like this. So both of the things are happening here. So first of all, we created a block of memory. Okay, a block of memory which contains many elements. So that element will depend upon how many from the user input. Okay, so you can see here I have taken the element, the size of the matrix is n, that means n elements a block having n elements will be created. Okay, and PTR will be responsible for storing that block, address of that block, and while taking input from the user to uh, enter the elements of the matrix. Okay, to enter the elements of the matrix, the values of the matrix, then we will assign each of the value address into each PTR different variable. Okay, separate variable, you can say unique variable. So we are assigning this address of this 5 into PTR 0, assigning this 4 into PTR 1, so something like this. So we do this 8 once. Okay, so simultaneously we can say. So that is the thing happening here, and also you can see here this is the way of printing out the values. Okay, you can see. Also we can also do something like this. I think so. Bit of I. So same as in array indexing, right? Let's say 5 and 5, 4, 3, 2, 1, and you can see the values are printed 5, 4, 3, 2, 1. And it's not compulsory that you will give these variable names, that pointer variable names is 0, 1, 2, 3, 4. It is not compulsory. Okay, so you can give it anything. You can say here I am giving 2 and n plus 2 to n plus 2, and I'm giving 2 up to n plus 2. So now I will run this, and 5 elements, 5, 4, 3, 2, 1 are the elements of the array. You can see 5, 4, 3, 2, 1 has been printed. So in this case, this PTR 0, 1, 2, 3, 4, instead of this, it is like 2, 3, 4, 5, 6. Okay, something like this. So whichever is assigned at first, whichever value is assigned at first in the first block, whichever value is taken input, that will get to the first block obviously, and that first block is that address is assigned to whatever variable name, that pointer variable is given in the first place at first. Okay, at first whatever pointer variable is given, that will be assigned, that address will be assigned to that variable. Okay, so that is it. The main thing is this. I don't know how much I was able to make you understand. So now we will create 2D array using dynamic memory allocation. So let's do this. So for first of all, I should explain the, just a second. I will explain the logic behind this again. So for 2D array, okay. So for the 2D array, it is little different because we use double pointer in this case. Because we use double pointer in this case, that means we are storing the address of the pointer. Okay, so pointer is storing the address of the value of the array, right? And we are, by using double pointer, we can store the address of the pointer, that is storing the address of the value. Okay, so there is that is the main job of double pointer, double asterisk pointer. Okay, so we will make a int star star PTR, something like this. So in this way we will create a double asterisk pointer. Okay, double pointer we can say. So, and this PTR will be pointing the address of this block. So let's say we give the size of the array is 3, then this kind of block will be created in the heap memory. Okay, and this address will be associated with this PTR. Okay, so this address will be associated, this block address will be associated with PTR, and we can give it any name, right? We can give it any name, each of the elements of the block. So each of the units of the block, we can give it any variable name we want, right? So we have already talked about that. And then we take input of number of rows and number of columns from the user. Okay, and the rows, the number of rows is associated with this block. Okay, that we will create directly by using the same thing that we have done in 1D array. That same thing we will do to you create the number of rows only. Okay, and to do the number of columns, we will use the double pointer. Okay, so double pointer means I think I should write the code first. Something I'm not able to explain using namespace. First of all, I will write the code and then I will be explaining. So let's just return 0 int m out enter the size of the relay. Okay, and then instead of C we will be taking input inside m and n. So m will be number of rows and n will be number of columns. Okay, then we have taken input. Now we need to allocate the memory. So for that, int star ptr. So we are creating a double pointer, a new int and m. And so we are giving the size of the array here. Okay.
This one.
What is it saying, bro?
I don't put a thing to what
I think the okay. So
my well,
if I directly give value, then what will happen? Type. Okay.
Eddie.
I think now it is fine. So yes, bro. How can I do the mistakes like this? So this should be a pointer, because double pointer will store the address of the pointer, not the value. Okay. Now we have made the rows. Now it's time for the column. So for column we will use column loops for that. Int I equal to 0 to I less than n, I plus plus.
Is any with so to put that.
Oh, whoa, bro.
Italy, that I'm messing about thinking. Do you guys need to be in a position?
So this would be the correct way of doing that. So I was little mistaken. Okay. So what are we going to do? So you can see this PTR is pointing. This PTR is associated with the address of the whole block. This block that is created. So this block, something like this, we can visualize it like this. So it wouldn't be like this, obviously. So but we can visualize it like that, right? So this kind of blocks are created, and this PTR is referring to the address of this block, and we can give PTR to anything, right? These variables, each of the elements we can give any variable name. Here you can see the block. So PTR I would be associated with this address. So we are now inputting the values. We will be now creating the values. So what is this line doing? This line is creating a 2D matrix. This line is creating the 2D matrix, and you can see here PTR. First of all, let me do this thing. Let me keep each block as PTR 0, PTR 1, and PTR 2. So actually, yes, it will store the address of PTR 0. What is PTR 0 now? So PTR 0 is this whole row. Okay, so this whole row is the ptr0 actually. Okay, and you can see here this this matrix, this array that we have just created now, this is creating this 2D array. Okay, this 2D array is created by this line. So this line is creating the 2D array, and ptri is responsible for the storage of this address of this whole block. Okay, so ptri means ptr0 or ptr1 or ptr2. That means this block, whatever this block is storing, okay, whatever this block is storing, that is responsible with the rows on this array that we have created. So it is so complicated. I am making this so complicated, bro. How do I resolve this thing? So let's just see the name of these variables. What would be the name of this variable, so that I think it would be more easier to understand after that. Maybe let's see, ptr0 in the 1. Okay, and then oh sorry, and then ptr0 2, something like this. Then ptr1 0, then ptr1, then 1, then ptr that would be 1 2. Okay, so we can just copy this whole part and
Really some
paste it here and change this one with 2 simply. So this is the thing that is happening here. Okay, so now I will be taking input of from the user, that elements of the arrays, and after that the blocks would be named like that. So the block addresses, the each of the element of the arrays, the addresses of the element of the arrays would be stored inside the pointer, which will have that kind of name. Array is less than m I plus plus. Then for int j equal to 0, j is less than n, j plus plus. Okay, now here we will take input, that is we will store it inside ptr I, and then there j. Okay, now so this line bought this line from here, and I will keep this line here. Okay, now let's run and see.
I'm not that really let's see about the extra no from the nose a little better.
Size of the array would be let's say 3 comma 3, elements 1 2 3 4 5 6 7 8 9, 4 5 6 7 8 9. Okay, it is running well. So the mistake is, there is no mistake, but I need to print out each of the elements here. Separate lines. So I will give backslash n, no, not here. I will give backslash tab here, okay? And inside of first loop, I will give backslash n here. Okay. Yeah. Now it's good. Okay, so enter the size of the array 3 comma 3, 1 2 3 4 5 6 7 8 9. 8 9. Okay, 1 2 3 4 5 6 7 8 9. So dynamically allocated and dynamically then printed the value. So this is how we can create 2D matrix dynamically in C++, but it is more easier to access in C++ than C. You can see that thing here. So in this line we are creating this blocks, and in this line we are creating this 2D matrix. Okay, and the assignment of the 2D matrix, the variable name and all the elements, that is happening here. Okay, so that is it. That is it. So uh, double pointer will make this end of block. We can resemble it like that. We can remember it something in this way. It is creating this kind of array, or we can say it is allocating this in this time in vertical, right? And then the second, that is PTRI. Whenever I do allocate using PTRI inside a window, then in that case it is created like this. Okay, like this, and we can just simply say that it's like this, and I can just simply say that something like this is happening.
Material. Any other support town.
So this kind of only three rows, that sorry, three columns, only three columns are getting allocated, and this is applicable. This is for every row. This also, and this also. Okay. This. So something like that. So we can just understand it like when we allocate dynamically by using double pointer, then it will make the rows. Okay, it will make the rows. And when we allocate it using again single pointer after the double pointer, then okay, then it will create what? It will create the volumes. Okay, that is the number of volumes. So that is it. That is the main thing here. Yes, I think I'm finished. Okay. So to access the inside, we don't need to use the pointer in that case. Okay. That was more easier. I made it little tough and get confused, but that was easy. That was easy, bro.